Welcome to a guest webinar for Maptitude. My name is Alex Arifuzzaman, and I will be talking about advanced trade areas. This is a 30-minute webinar, so I don't have that much time to go into too much detail, but I wanted to cover some of the key uses of Maptitude with respect to trade areas. So I'm glad you're here. Thank you for watching. The plan today is to introduce you to some trade areas and show some methodologies that are available in Maptitude. And my hope is that by the end of this seminar, you will be able to use Maptitude to use beginner, intermediate, and advanced trade areas. A little bit about myself. My name is Alex Arifuzzaman, and there is my email address. I have been working in this field for over 20 years, lots of experience with lots of different retailers all around North America. I teach marketing, geography, and analytics at Toronto Metropolitan University, formerly known as Ryerson, and also at the Schulich School of Business, where I teach in the MBA program. The key area that I focus on, in addition to all the spatial analysis, of which there is a lot of data coming on stream, is linking it with finance. And by doing that, you can make some informed decisions, because that's what it's all about in business. And I'm based in Toronto, Canada. Now, in today's presentation, I used Costco as an example. I'm not affiliated with Costco, and everything I've shown is publicly available data or data that is provided in Maptitude. What I would like to do today is talk about basics of trade areas and then go through a few different examples. And I'm kind of working my way up, and there is kind of a method to the madness in showing how each different type of trade area improves on the previous methodology. So trade areas. What is a trade area? Trade area is basically what it says there. It's a consistent methodology to determine the spatial reach of customers around a retail location. Keyword is consistent, because in order to compare and contrast different trade areas, the methodology has to be the same. That's very important. Every methodology has advantages and disadvantages, but whatever you do, when you do it for multiple locations, is to be consistent. Now, a lot of data with respect to consumers is available. You can get loyalty data, zip codes, postal codes, telephone data, all kinds of stuff. And it's becoming even more available with the advent of all the spatial data from social media. And that's great. And you can map that and create trade areas. And that is a great way to do it. The issue is that methodology only shows you what is happening now. In order to get some really useful analysis, you want to do what ifs. What will happen? What could happen? And for that, you need to create model trade areas. So that gets you to the second methodology. And that's a trade area model that you can apply to a set of locations. And then you can do what ifs, because you could run it on one scenario, maybe change your locations around, run it again, and see what changes. And Maptitude has some excellent methodologies to create trade areas. Okay, we're going to start with the basics. Radius bands, everybody knows that. It's just a circle around a store. To do radius bands in Maptitude, you go into Tools, Analysis, and Buffers. And I've done some radius bands for Costco. So the Costco data, by the way, is also available from Maptitude. And this is a 5 kilometer or 3.1 mile radius band of the Costco locations in Toronto. It's very easy to do. The problem is, if you do this one, 5 kilometers, there's a lot of gaps, areas that are not covered. And people in those gaps probably do shop at Costco. So it undercounts. So what's the solution? Well, you might think, just make them bigger. Here's a 10-kilometer radius band. So now most of the areas are covered. So that's good. But look at what happens. There's a lot of overlaps, and overlaps are not your friend when you're analyzing trade areas, because it gets into double counting, triple counting, and it becomes very complicated. If you said, for example, did the populations of each radius band and summed it up, it would not be the sum of the Toronto population. It would be much, much higher because of all the overlaps. So that is radius band. For quick and dirty, or just the general information around a single location, it's okay, but it's not a great methodology because of the overcount and undercount issues. So what can you do? And even though there's a lot of overlap here, there's a lot of undercount here. So again, radius bands are not the greatest. So there is one solution. It's called a Theissen polygon. And in Maptitude, it's under Tools, Analysis, Straight Line Influence Areas. That's exactly the same as a Theissen polygon. And I ran them, and this is what comes up. So basically what it does is it creates a polygon around each location where everything within the polygon is closer to the location in the center of it than any other one. So in other words, every polygon shows you the areas that are closest to that Costco in the center, which is great. It is a very good methodology to use. It's much, much better than radius bands, and it does not have overlaps, and it also does not have undercounts. And this is the menu under straight line influence areas that I used to get that. But there is an issue. When you run it for, say, all the Costco locations in Canada, the one I just showed you was zoomed in down here around Toronto, but you ran it for everything. And it's good for the internal areas. But the problem is, if there is no location beyond the edge of your trade area, it just continues on forever. Right? So from here up to here could be 1,000 miles. But even though this is 1,000 miles away, this is still the closest one, which means it's probably way too big. So that's the issue. So straight line influence areas is great, but it has that issue. So how do you solve it? Well, you can do it in Maptitude, and I find this to be really useful. You can trim them. So what do you trim them with? Well, what you could do is create a buffer, which is the maximum reasonable distance from which customers visit a location. More destination retailers will have a further one. Convenience retailers will have a shorter one. Do the buffer around all locations, and then trim the Thiessen polygons to those buffers. And this is how you do it. You do a buffer, just like in the radius band from the first methodology. In this case, I selected 60 kilometers. And I also did not select separate buffers. I'm just going to have one single buffer, which is a polygon of 60 kilometer distances around all the Costco locations. And I also did not calculate demographics. Okay, and what we're going to do, it's called cookie cut. We're going to cookie cut the Thiessen polygons with this buffer. I'll call it Costco buffer. So once I've created the 60 kilometer radius bands, that's these pink circles you see here. And the Thiessen polygons are already here. Okay, so how do you cookie cut? It's called clip in Maptitude. And you go to Tools, Editing, Clip Layers. And then this is what you want. Clip using Costco buffers. That's the circles we just created. And the only one we want to clip is the area of influence. And that's the Thiessen polygons. Then I always like to add layer to current map. It just saves you a step. And that's it. It'll chug for a few minutes. And this is what the output looks like. This looks like a radius map, but it's more than that. If there is no other Costco within 60 kilometers, then it is a radius. But if there is one, then it gets split by the internal Thiessen polygons. You can't see that too clearly here, but you zoom into Toronto, this is what you get. And this is a much, much better rendition of what the trade areas would look like. So Thiessen polygons. So they internally, it's the Theissians that are the cutoffs, and externally, it's a 60-kilometer buffer. It's a really good way of doing it. Okay, that works. Now there's one more issue. It doesn't really affect the data, but it affects the cosmetics. And that is, you can see some of those 60 kilometers, like this one here in St. Catharines, spills over into the United States, where you got the lakes, etc. What you do is you trim it again. But this time, instead of trimming it with the 60-kilometer buffers, you trim it with the boundary. In this case, I'm picking the boundaries of the provinces. In the US, pick the states. And this is how you do it. So this time, clip using province. In the US, you can do state. Select all the states that the store covers. And this time, you don't clip Costco buffers. Instead, you clip area of influence 1. This is the original area of influence. This is the one that was clipped with the 60 kilometers. You run that. It might take a few minutes, depending how complicated it is. And that's what it looks like. And personally, that is a really good way of presenting the data. And I found for retailers that are destination draw, it is a very accurate methodology of estimating the trade area. Now, if you have your own locations, you can map using your own data. But say you want to know what the competitive trade areas are, you can do that for your competitors. Very useful. Now, there is one problem with Thiessen polygons, which is it uses the straight line distance. Straight line distance does not include the road network, such as highways, and it does not include such as rivers or lakes, etc. So how do you solve that? For the Thiessen polygons, the final step, once you have calculated the trimmed ones, is you want to add in the demographics. And Maptitude makes that very easy. You just go to Overlay, Tools, Analysis, Overlay, and make sure the final Thiessen polygon is your working layer, and then just select the layer you want to populate it with, and hit OK, and it'll calculate the demographics for each one of these trimmed Thiessen polygons, and you're done. You don't want to use the demographics from the original Thiessen polygons because it will include the demographics for these enormous areas. And then you're done. Okay, now there's another thing, which is a drive time trade area. Let's start off with just what is a drive time. Maptitude does it under routing and directions, drive time rings. And drive time trade areas are better than Thiessen polygons because they take the road network and physical barriers and speeds into account. So it makes it a little bit more realistic in terms of the consumer decision-making process of where to shop. But there are a few issues, such as drive times could vary depending on if it's rush hour or not. And there's issues with overlap. So let's take a look at that. By the way, you can adjust the drive times in Maptitude. So a retailer might have a different drive time range depending if it's rush hour or on a weekend. So keep that in mind. And you can always calibrate it with your existing data. So here's Costco again. This time we did 8-minute drive time rings. Just like with radius bands, same issue. We have good trade areas, but there's a lot of gaps. So it's not covering the entire region. So make the trade areas bigger, the drive times bigger. This is 8 minutes. When you bump it up to 16 minutes, look what happens. You get into that same issue that we had with the radius bands, that there is too much overlap. So how do you solve that? Well, this is one of the methodologies I really like in Maptitude, which I have not seen in any other GIS software. And what it is, it's creating the equivalent of a Thiessen polygon, but instead of a straight line distance, it uses drive distances. How do you do that? It's called drive time influence areas. It's built into Maptitude. It's extremely computer intensive, which is why I think not a lot of GIS systems have this, but it does work. Originally, when I wanted to do all the Costco's in Canada, my computer could not do it for all of them. It could do it for about maybe half of Canada, but then I upgraded my memory to 64 gigabytes, and now I can do all of Canada, or I can do all of the United States. So keep that in mind. It's because it needs to calculate basically the drive time for every point to every store, basically, which is billions calculations. To get at it, you go through tools, routing and directions, drive time influence areas. Basically, it combines Theissians and drive times. It's basically a Theissen polygon, but not on straight line distance. It's based on drive times. And it eliminates all overlap. That's the beauty of it. There's no double counting. In my opinion, it's the best methodology to calculate modeled trade areas automatically, but it requires heavy duty computing. All right, and I'm not going step by step because a drive time for all of Canada might take on this computer half an hour, so I don't have that time. But if you want step-by-step instructions, there's a video on the Maptitude Caliper website on how to do it. And this is what the output looks like. So again, for Toronto, what I did is I did a 15-minute drive time. So what it does is the edge of each trade area is 15 minutes of drive time, but the internal edge is where one store is closer than the other. So this is all of Costco in Toronto. And as you can see, it is different than the Thiessen polygons, but it covers pretty much all the areas. And the gray are areas that are between 15 and 30 minutes of drive time, which is probably, I would say, this inside is the primary trade area and the outside is the secondary trade area. And you can populate it with demographics and all kinds of other information using the same overlay function, and it's extremely useful. In my opinion, it's the best methodology to do automated trade areas with no information other than the retailer name. To do it, you select this, you select which locations you want. You can do all of them or selection, which you select before doing this menu, and you can weight it. Maybe some stores are bigger than others, maybe use the square footage, and it will give a higher weighting to it, and you're minimizing travel time. You can also do minimizing distance, which sometimes, or like road distance, which sometimes is necessary if you want, if it's based on how far it is. It's not so much for trade areas, but for routing and networking, it's useful. And here's where I put in 15 minutes. And you can also calculate the demographics, and there you go. It's good to go. Again, this is an amazing methodology that I have not seen anywhere else, and it's relatively easy to do, even though it's really, really heavy duty. Okay, next we have nearest location drapes. Okay, this is a little bit more complex, but it's really useful. And let me show you how that works. Basically, what we want to do is the reverse of distance calculation. We want to calculate the distances of every point or every polygon of such as a block or a census tract to every retailer. And then we want to find which is the nearest one. So Thiessen polygon calculates the nearest store to it, but this calculates the actual distance of the nearest one, which is actually a heavy duty calculation. If you try doing that in a database, it gets extremely complicated because it's n squared, and like 1,000 locations could be 1,000,000 references to calculate. So, but this lets you do it relatively easy. I do not know how Maptitude does it so fast, but this is the best way that I'm aware of. So what you want to do is you want to calculate here. It's under data view, new data view. So this is not done in the map. It's done as a database. And to see the database, you go to data view, new data view. So whatever the working layer is, it creates like a little table, like an Excel sheet with that. Okay. It looks like this. Then you select add field. And well, first you select modify table, then add field. And then here I created a new field called Costco dist. There's the format. I made it real 8 bytes, so that way you can do really huge ones and really small ones. And distance nearest Costco is a description. All right. So it creates a field. This field is blank. Now you have to populate it. You do that by click on the new field. You right click on it at the top, right up here. Right click, and then you select fill. Then under the fill menu, select the layer that you want to measure the distance to. In this case, you want to do Costco locations. And we're going to fill all the features or all the rows with the distance to the Costco locations. Which Costco location does it select? It selects the nearest Costco location. So give me the distance to the nearest Costco location. Again, I'm in Canada, so mine is in kilometers, but that's all you have to do. Hit OK, and it populates it. Now I picked dissemination areas. Dissemination areas are similar to, I don't know, your census tracts in the US, and there are 50,000 of them in Canada, and it's now calculated the distance to the nearest Costco in kilometers to each of those 50,000. I didn't put this into a slide, but say here in the US, you want to do Costco, you can add in Sam's Club, and then repeat the process for Sam's Club, and then you will have 2 columns, and you would be able to, just by subtracting them, figure out what is closer, Costco or Sam's Club, to every block group in the United States in 15 minutes. So there you go. So that's how you do it. And if you want to look at the output, what you do is you create a thematic map in Maptitude, which basically is this button right here, color theme map wizard. Make sure you have the demographic file you want, which I picked DA, you might pick block group or census tract, and then select Costco dist, which is the field we just created, and map it. And that's what it looks like. So this is the distance to the nearest Costco. And by the way, this is done for all of Canada. I just zoomed into Toronto. And in kilometers. But as you can see, a lot of Toronto is in this, say, 5 kilometers or less to Costco, but there are some areas that are further. Within Toronto, which is basically this area, this is kind of getting into suburbs. The furthest distances to a Costco are in this area. This is around 401 and 409. This is the furthest. There's also, I guess, a bit down here, downtown east. But this is it. And guess what? There's a new Costco opening in a couple of months right here. So I don't know if Costco used this methodology or this methodology revealed some of Costco's thinking, but there you go. I find that really useful. That's it. So thank you. Thank you for participating in this very quick webinar, but I hope you have some additional insights as to trade areas and doing trade areas in Maptitude. I find it really easy and useful to do. So We'll leave the presentation here at that. This will be the end of the recording, but I will stick around and be happy to answer any questions that anyone may have. So, thank you.